Okay, so before moving to the further details, so first we will go through the outlines and then we will move further. Okay. So first I will be starting with your introduction part, and in the introduction part, basically I will be covering the introduction related to your machine learning algorithm. Then we will go for the different kinds of the learning algorithms which are available. Specifically, we are going to discuss supervised learning, and in the supervised learning, we will be discussing about the regression. So these are going to be the outlines. So in the regression, we will be covering all the variants of the regression, like the simple linear regression, polynomial, and the multiple linear regression. And after that, if time permits, we will go for the regularization also. That basically regularization is used for covering your to deal with a overfitting problem. So that we will cover at the end. So if the time permits, we will go with this regularization. Next thing is we will be covering all these. First, we will be covering the theoretical part, and along with that, we are also going to see how practically we can implement it, how we can use this algorithm to solve a problem. So first, I will try to demonstrate the things with the help of the numerical example, and then we will see it how we can do it using the programming. Okay. So for the programming, I will be using your Python, and all the experiments we will be doing on the collab. So yes, in the day before yesterday class also you have learned how we can use the collab to write your program. So the same way we are also going to use the collab to write all your programs. Okay. So before this is going to be the outline for your today's session, and yes, before moving further with the details, so all these slides which I have prepared and all the images which I have included here, so all these images I have taken from the different sources. So first, I would like to acknowledge each and every original author, the contributor, and because of them only I was able to prepare these slides. So yes, originally the acknowledgement is going to be all the original authors. So moving with the data science and your machine learning. So basically in 3 days, basically we have talked about what this data science is all about. And we have also covered about some of the basic aspects related to a data science, like the mathematical foundation of your data science, probability part also we have covered what exactly the data science is. So that was your first session, so that we have already done, right? Now, how it's going to be related with the machine learning. So basically, the data science, in the data science, what we are trying to do is we are basically trying to analyze your data, and we are basically trying to find the information which is hidden in your data. And in order to basically extract these information, we are going to use different tools. We are going to use the different algorithms. We are going to use different method or visualization way or a statistical way to basically take the meaningful or to take the informative sets of the information from your data. So that is the part with your data science, right? Now, what this machine learning is, basically the machine learning, it's basically going to deal with, or majorly it's going to deal with the model building process. So what this model is basically going to, model we are going to prepare from the data which we are having. And this model is basically going to contain the information which is present in your data. And this model we are building so that we could use it for the future prediction task. Okay, so that is the concept for your machine learning. Okay, and one more thing is, if you are having any doubts, so please post on the chat. So in between, I will be taking the question from the chat. Okay. So in between, if you're having any doubt in between related to the any of the concept, please post it on the chat. I will take it from there. So moving further, so this, like as I said, the data science basically it's using your learning algorithm. It's going to use the learning algorithm to deal with your data, to basically take out the information from the data, and this information possibly we are going to use in the future. So like you could see, these all are your machine learning algorithm, right? And it's come under in this big circle also, and it is also going to be a part of your data science also. So we will be using these different kinds of the algorithm to satisfy your different kinds of the requirement. Now, what could be a requirement, and in different kinds of the requirement, what we are going to do. So that we will be covering in your coming slides. Based upon the different requirement, you have to use the different learning algorithm. Firstly, one learning algorithm might not be very suitable for all kinds of the problems. So that part we will relate it in your coming slides. And also let me know if I'm going too fast. I will make myself constraint. Means I will slow down my speed. Let me know if I'm going too fast. So coming to your machine, why we are basically requiring the machine learning algorithm? Like we know that we want to perform all our tasks very fast, right? So in order to perform all our tasks, we would like to make our life very easy. So that easiness, it could be in terms of the comfort, that easiness, it could be in terms of the speed, that thing could be related to your performing your task very quickly, right? So now how this machine is going to help you in this case? Now, if we see the it is not the case for now. It is not exactly the case. All the tasks which human are able to do it very efficiently, machine is able to replace all those tasks. That is also not the case, and the vice versa also. Basically, in today's scenario, in some of the aspects, the machine is working very fast, machine is very intelligent. But yes, in the another scenario, the human are able to work more efficiently. The human are able to basically behave more efficiently, more accurately than the human, than the machine. And what the cases are, like suppose if we talk about the self-driving car, the driving of a car. So in that case, yes, we are having Tesla. Yes, that is working very. That is basically, yes, it is working very accurately. But yes, in some aspects, the human is more efficient compared to the self-driving car. So in this aspect, if you talk in this aspect, the human are still more efficient, more accurate than the machine. Now coming to the another part, suppose you are having the different, like suppose if you are having the millions of the documents. For example, whenever you are going for the searching any document in your Google, so it is quickly, it's going to within a second, it's going to show lots of result. It's going to display, right? And from those you can take out the important information. You can go through it. You can read it, right? So if you are having the lots of information, and from those lots sets of the information, if you want to take out some set of the information, so that task we can easily do with the help of the machine. But the same thing if you talk about the human, so yes, human can also do it, but the human are going to take lots more time compared to your machine. Right. So in this aspect, the machine is going to be more suitable option, more convenient option it's going to be. Right. Now coming to the another part of it, like suppose if you want to multiply this long number, right? So if we start multiplying all these numbers, so possibly we are going to take years of years to do this task. But the machine can do it very efficiently. Machine can do it very quickly. Right. So in that case, we can see the machine is more faster compared to the human. Coming to the another aspect, so the next one is related to your translation. Right. So in translation, like we are having the Google translations, yes, it is also working very efficiently, very accurately. Also, it is working, but yes, human are more accurate. If you're talking about in terms of the one language, the human are more accurate in their own native language compared to the machine. Right. So from this particular slide, we can relate it in some aspects, the human are more efficient, and in the some aspects, the machine are going to be more efficient. Right. We are moving in that direction where the machine is going to work more efficiently, more accurately compared to the human. But yes, still in today's world, the interaction of the human is required whenever we are performing a particular task. Okay. So now what this machine learning is all about. So basically the machine learning, basically it's about the task in case of the machine learning is we would like to make a model so that the model is able to work more efficiently than the human. Like the task as we are doing, the model or the machine should be able to do that task as efficient as human are able to perform the task. So that is our objective in case of the machine learning. Now here I will be playing these two videos, and these two videos I have basically taken from the YouTube only. And in this you will see how the machine is going to learn from the data, and once it is able to learn from the data, how it's going to work in the environment, how it is going to work in a particular situation. So first I'm going to play this first one. So like here in this case, what we were doing is what this person is going to do is person is writing a set of the rules in order to perform a particular task. So like suppose the task is related to something classification. So he or she is going to make some set of the rules, and based upon that set of the rules, the classification is going to be. Right. In this second one, what it is going to be, the human are going to provide the, basically here we are going to feed lots of the data we are going to provide. Right. Now from all those data, the machine is going to basically learn from the data. How means if this is the input, then what should be the output? Like here you could see the machine is going to learn from the data. Like if the picture, if the structure is like this one, then it is going to be the cat. If the structure is somewhat this one, then it is going to be dog. So basically here what the machine is going to do, machine is basically going to learn the information which has been provided as an input, and it is going to adjust itself. It is going to basically adjust the parameter of the model, and based upon that adjustment of the parameter, it is going to work in the future. So basically once you are done with the model building process, and this model building process basically we are going to do based upon your based upon your data, it is going to, right? So once it is done, it is going to work, it is going to basically perform a particular task, right? The classification thing, like the whether the particular image is related to your cat, or whether the particular image is related to your the dog. So for that, you have first provided your data, and now once you have provided your data, model is going to be learned from the data, and once we are done with the model building process, you can use it for the classification of this, right? So this is the again the another example related to your chess playing. So first, lots of the moves are going to be feed into your basically lots of the moves are going to be feed into your system. Now it is going to analyze all those moves, and based once it is able to analyze all those moves, it is able to learn the pattern, and now based upon that learned pattern, it is going to work in the past, right? So that is the case with this one. Now coming to the second part of it. So here in this case, the basically the machine is going to analyze the environment, and based upon the analysis of the environment, the machine is going to take the turn. Machine is going to basically this car is going to stop. The car is going to take the speed. It is going to slow down. Now, how this car is basically able to analyze the environment, right? So here in this case also, basically the car is going to analyze the environment, because before deploying it, lots of the information in terms of the experience has been supplied to this model. And once this model is able to learn from all those experience, now this model has been used to use in this car, and now this car is going to work accordingly, because this car has learned the information from all the experiences, all the information which has been supplied. So this is just related to your again, it's related to your learning from your data. Like you could see, the person is not driving the car itself. It is going to analyze the environment, and now based upon the analysis of the environment, it is going to take the move. It is going to speed up, and it is going to slow down. Right? We will see exactly how means whenever we are saying that it is a model, and it is learning from the data, what exactly the meaning of the model preparation, what is the meaning of we are using the model for the future prediction. So that part we will see, right? So don't worry about that. I will be covering all these cases. Sorry. I will be covering all these cases, how you can prepare your model, how you can adjust the model based upon your example which you are going to feed it. And once you are done with the model building process, how you can use it for the classification. So that part we will see, right? So for now, you can go through it later point of the time. I will be sharing this slide with you. Okay. Now let's come to your exactly what learning is all about, and how the humans are learning, and how this information or how this capability is basically the researchers are basically trying to transfer to the machine, right? Now let's see this picture. So this picture, hopefully all of you are able to recognize. So this picture is related to the Ajanta cave, right? So now how we are able to recognize that this picture has been taken from there only. Now we are able to basically say it, or we are able to analyze it, because somewhere, somehow we have encountered it personally, or we have seen it into your internet, or someone has explained us about this, right? So now whenever you are basically encountering anything or any event, any picture or any situation, so basically at that time, knowingly or unknowingly, you are basically holding the information related to that particular object. Right, like suppose earlier we are not knowing the different kinds of the fruits which we are able to recognize today, like the what is the means which fruit is the apple, which one is the banana, which one is the grapes. We were not able to basically we are not able to recognize in the earlier days, right? But now we are able to. Why is it the case? Because we have encountered those foods so many times. Someone has explained us about those foods. So when these things are happening, so at that particular time, you are able to store the information in your means within yourself, and whenever it's required, you are going to use that. So that is the case with respect to the learning. So in case of the human also, you are learning from the data, and over the number of the time, or over the number of your years, you are refining, or you are basically revising that data, you are refining that data, you are adjusting that data, or the knowledge which you are, right? So now this learning concept, it's not a very new concept. This particular concept has been introduced by Plato, and that was 2300, nearly 2300 years ago. And what concept the Plato has given is, the Plato has given this concept that whenever you are able to recognize any object, so at that time, basically, you are having a prior connection. So when you are having a prior connection with the object, you are able to recognize it. And that we all can relate it, means how the newly born child is able to recognize his or her mother. And what is this? How it's means, like, this is really a very amazing thing, how the newly born child is able to recognize his or her mother. So according to the Plato theory, the newly born child is able to recognize his or her mother because the child is having the prior connection with the mother. So because of that prior connection, the child is able to recognize. So now according to the Plato theory, can we conclude that if you are having the prior connection, then only you are able to recognize it? So that is basically come as a summary. It comes out that if you are having the prior connection, then only you are able to recognize the object. Now, next concept, which the very important concept which was missing in the Plato theory, that is the ability to learn in your current environment. So this Aristotle, who was also the student of Plato, and he has given this concept. He has criticized his teacher's theory, and he said that the one important aspect which is missing in the Plato theory is ability to learn and adapt in your changing environment, in your current environment. So yes, it is true that when you are having the prior connection with the object, you are able to recognize it, but in your current existence also, in your current environment also, you are learning, you are adapting the new things also, which is going to be there. So that thing was missing in case of your Plato theory, and that has been covered with your Aristotle. Okay, now summarizing all these parts, what this machine learning is all about, and the experiences which we are saying, what is the experience, and how basically we are going to learn from the experience. So this machine learning is basically it's a subfield of your artificial intelligence. Basically, it goes like this. So first, you are having the artificial intelligence. This is a big umbrella In this big umbrella, you are having a small one that is your machine learning, and in the machine learning, a small part of it that is we are going to refer it as in the deep learning, right? So here, in case of the machine learning, it's a subfield of your artificial intelligence, which is going to use some statistical way to learn from the data, and over the period of the time, it is also going to improve its learning, or it is going to improve the knowledge which the machine has gained from the data. Right. So if you wanted to, like, suppose you have created model one at one particular point of time, and if you want to, if you are having some more data, so what we can do is we can refine this model further, and in this further model, basically you are going to feed this new data you will be supplying, right? So from this new model, again, it's from this new data, again, this model is going to adjust itself, and this model we can use it for your prediction or your classification. Okay. Now, the three important thing in case of the machine learning is, the first one is your experience. Next comes is your particular task which you are going to perform, and the third one is your performance. So, if the performance in your particular task that is measured with P is improved with the experience, so that is basically comes under in your machine learning. Now, what could be your experience, what could be your task, and how we can summarize or how we can quantify the performance of your model, and why it's really required to quantify the performance of your model. So first, coming to your general task, what could be your task? The task could be related to your classification task, it could be related to your regression, it could be related to your grouping of your object, it could be related to your translation or some disease identification, something. So these are going to be different kinds of the tasks. For these tasks, basically, we need to prepare the model. Again, it's going to depend upon what kind of the requirements you are having. And that requirement is basically going to be your task, what you would like to achieve. So that is going to be basically your task, whether it's your house, whether the prediction of your house, or whether it's whether it's a classification, whether the person is having a disease or not, whether the person is the graduate student or the master student. So we can have the n number of that task. So whatever your objective, so that is going to become under the category of your task. Coming to your experience, so basically experience we are going to provide in terms of your data, and the way you are going to learn from the data. So based upon that learning, you are going to have the different kinds of, the way you are going to basically take out the information from the data, and that you are going to feed it into this, based upon that learning, you are going to prepare the model. So that is going to be a learning part of it. It's how it's going to basically take out the information from the data, how it's going to prepare the model. So that is going to be part of your learning, right? Now, next, coming to your performance measure. So basically, why we are requiring the performance? Performance measure are basically performance measures we are using to quantify how good your model is. Like, once you have prepared your model, suppose here I'm saying that I am having, I would like to prepare a model for the classification of a disease, whether the person is having a disease or not. Suppose it's related to, suppose here I'm writing C for I'm using a class, and suppose D I'm using for your data, and M I'm going to use for the model, right? So now this M I am going to prepare based upon your supplied instance. Once you have prepared this model, I am going to supply some unknown instance that we are going to refer it as in the test instance. Now it is going to state that the what is the class, whether the class is the positive one or whether it's a class is the negative, right? So now what this model is basically doing is, model is saying yes, it's a positive, or whether or the instance is a negative. Now, how good this prediction is, whether it's just the random prediction it is doing, or actually it is doing the correct prediction. So we need to have some way to quantify the model which we have prepared, whether it is working well or not. So for that, we are having the different performance measures. So for your, if we talk about the classification, so for the classification, we are having the accuracy. Accuracy, we are having precision. This is the another way to quantify the performance. We are having the recall also. We are having the F1 score. So there are n number of the measures to quantify how good your model is. In case of regression, which we will be covering in later point of the time, In case of a regression, you are having the R square, root mean square error, mean absolute error. So these are the ways with which I can quantify how good my model is. And this is really, it's really a necessary step to quantify how good your model is. If you are not able to quantify how good your model is, you won't be able to claim it. Yes, the model which you have prepared, it is going to work best, it is going to work better for your unseen instance. So first you need to quantify, you need to test it how good it is working in the current situation. Then only we can go for the deployment, and we can use it for the future prediction. Okay, so that is the case. That's why the performance measure is really much required in order to quantify how good your model is working. Majorly this accuracy is taken. So this accuracy basically it's quantify out of total number of the instances how many correct prediction is there. So that is basically defined in terms of your accuracy. So now if we relate all these concepts with an example, so suppose here what the task is, here the task is to recognize handwritten digit we would like to recognize. So here what the task is to identify what kind of the digit or what digit has been written on your supplied image. Like suppose this all your image, and that is all the images are basically related to your handwritten letters or handwritten digits. So here your task is going to be the recognize or you to classify the digit which is present in your image. So this is your task. Coming to your training example or training experience. So in case of a training experience, you are going to supply lots of the images, and in all those images, we are going to have the different variants of the pertaining to your different digit. Like sometimes, like here, it is 2 is written in this way. Sometimes it may be written in this way. Sometimes it's written in this way. And this is 3 is sometimes it is written in this way. It is written in this way. So all these are basically going to be your experience, or it is going to be your example which you are going to feed into your model, right? Coming to your performance, so the performance that I have just explained you the performance measure, we are having the different kinds of the performance measure. So for now, just take it the accuracy. So accuracy is quantifying out of total number of the instances, how many instances how many instances or how many images you are able to classify them. Like here in this case, the example is related to your the digit recognition. So out of, like suppose if I'm supplying 100 images, and for all those 100 images, I will be doing the prediction. So in your prediction, I will simply count how many images the model is able to classify correctly. So that is going to be your accuracy for your created model. Okay. Now, how whole this process is going to be? So basically, this whole process is going to be in a two part. The first part is going to be refer it as in the training part, and next is going to be refer it as a prediction, or this is also refer it as in the testing part, or testing phase also it is referred as a testing phase. And this is your training phase. So in case of your training phase, basically you are going to supply the lots of data. Basically, you will be providing as in the training instances. Training instance. Okay, before moving with that, so basically, what is the training instance and what is your test instance? So basically, for your training instance, this training instances we will be using in a training phase. The first thing is it's that we will be using in your training phase. Here you are going to have the instances. The instances basically you will be covering in terms of your features. Along with that, you are also going to provide the class level information. So these information you are going to have in case of your training instances. And these information you are going to supply or you are going to use in your training phase. That means you will be using the features along with the class level information, and based upon that you will be preparing the model. So this training instance, it could be from your medical domain, it could be from your financial domain, it could be from your transport, it could be from your nature. So from there are n number of these sources. From those sources, you could have this training instance. So you can have this training exam, right? So now based on, like, suppose if I'm going to take the example of this one. So suppose this is the medical data. So suppose this is your medical. Okay. So here what you are going to have is you are going to have the patient information. Along with the patient information, you are also going to have the whether the person is having the healthy person or whether the person is the diseased person. So here the as in class level, you are going to have the healthy person or the person is the diseased person, not an healthy person. So this is going to be your class. And here you will be, in case of your features, it could be related to what is the height of the person, what is the weight of the person, whether the person is having a particular symptoms the person is showing or not. So these are going to be all your features. So in case of your machine learning algorithm, we will be supplying this information, this complete information we are going to supply. And now here you are going to have some machine learning algorithm you are going to have. So this learning algorithm, it could be a support vector machine, it could be your it could be your logistic regression, it could be your random forest, it could be your linear regression. So these all are your learning algorithm. So these learning algorithm, basically it is going to learn from the data, and this is going to be the iterative process. It is not the case you are learn at your one step and then you are done. It is not the case. It is going to be iterative process. That means over the number of the time you will be repeating this process, the learning from the data. This phase you are going to repeat it numbers of the time. And once you are satisfied with the performance of the model, then you are going to deploy that model. So whatever changes you would like to make, that changes you will be doing in your training phase. Once you have deployed the model, so that after that you are not going to check, you are not going to make any change. You will be just using the model as a black box. So before that, here you are going to make all the changes. If you want to adjust any parameter, so all the adjustments are going to take place in your training phase. Once you are satisfied with the performance, like that's why the performance measure which we have covered before this, like the accuracy. So once you are satisfied with the performance, then only you are going to deploy the model. If you are not satisfied with the performance, you are going to iterate or you are going to repeat this process again. So once you are done, you are going to deploy. Okay. Coming to this part, that is unseen part, that is also refer it as in the testing one. So in case of your testing phase, basically you will be using your test data, and that test data, you are just going to supply these features. We are just going to supply this feature and we will be using this model as in black box. So you're just going to feed this information, and based upon this feeded information, it is going to say whether the person is having the disease or whether the person is the healthy person. So here you will be making all the changes, but in case of a testing phase, you are not going to make any change. You're just going to use the model as in black box. So that is the case with respect to training and your testing phase. That is also referred here as in the prediction phase. So hopefully till this point it is clear to everyone how this training and testing phase is going to work. We will be covering how exactly this learning algorithm is going to learn from the data, how this learning, based upon this learning, how we will be able to prepare the model and how we could use the prepared model for your testing. So that we will see in your coming slide. So for now, is it clear to everyone how this training and testing thing is happening? Okay. Let me know in between also if I am going too fast, I will make myself slow. Yes, so one question is related to how the trained data is basically giving the accuracy. So like suppose, let me clear it. Suppose, for example, here we are having some training instances. We are in 1, 2, 3, 4, 5, 6. Suppose 6 example we are taking, okay? And suppose these all are your features. Feature 1, feature 2, feature 3. And with respect to this, you are going to have some set of information with respect to each of your instances. So if we talk about this particular part, so this particular part is basically, it's a matrix only, and the dimension of the matrix is 6 cross 3. 6 because you are having the 6 number of instances, and 3 because you are having the 3 features. Like suppose the feature is 100, so in that case it is going to be 6 cross 100. So it's going to depend upon how many number of features you have. Now, as it is your training instance, so that means you are also going to have the class label. So this last one is going to be a class label. So here you might be having, like, suppose if it's your binary class classification problem, so in that case, for some instance it's going to be 0, for another instance it is going to be 1. So these are your class label with respect to your with respect to each of your instances. Now, how accuracy is defined? So what I said is, for now, just take it as in the black box, like you have prepared this model, right? So this is your model, right? Once you have, why we are preparing model so that I can use it for the prediction, right? So suppose you have prepared this model based upon all these training instances. Now I would like to test it how good my model is. So in order to test it, what I am going to do is I am going to supply these instances. This I'm explaining with respect to training, not with respect to testing, because the question has been asked with respect to training. So that's why I am going to explain it with respect to the training. For the testing also it can be done. So now if you wanted to quantify how good it is with respect to your training, so what you are going to do is, with respect to your prepare model, you will be supplying your training instances. So here what I am going to do is I am going to supply my training instance, right? So now when I'm going to supply, it is going to say, like suppose all the instances I have supplied as an input I have supplied to the model. So for 1, it might be saying as in 1, for 2, it is saying as in 1, for 3, it is saying as in 0, for 4, it is 0, for 5, it is 1, for 6, it is in 1, right? So now what this class is, basically, this is your actual class which you are having in your actual instance, in your data set, and this is your predicted class. Right? This is your actual class and this is your predicted class. Now, what should be the class label for this? The class label for this should be 0, but you are getting it as in 1. That means it is a wrong prediction. For this, the class label should be 1 and you are getting is in 1. So it's a correct prediction. Coming to this one, it should be 1, but you are getting it as in 0. So that means wrong prediction. Coming to this part, so it should be 0 and you are getting 0, correct? It should be 1 and you are getting 1. It's also correct. It should be 0, but you are getting it as in 1. So out of this fixed number of the instance, how many correct prediction you have done? 1, 2, and 3. So that means it's your 50% only. That means your model is 50% accurate. For 50% of the instance, it is able to work correctly, and for the rest 50% instance, it is not able to work correctly. So that way, basically, we are going to calculate the accuracy for your training instance. The same thing you can do it for your test instance also. So for the test instance, so in case of a test instance, basically, in some case, it might be means when you are basically testing the performance, when you are basically judging or quantifying how good my model is going to work, when it has not been trained on a specific kind of the instance. Like suppose you are having the 100 number of instances, suppose you are having, right? So normally what the approach is, basically we are going to divide this 100 instance into your training and testing. Training test, that means I will be preparing my model on these set of the instances and I will be testing my model on these set of the instances. And why we are doing this? Because what our objective is? Our objective is to test it how my model is going to work in a case for which we have not trained it, right? So in order to test it, those cases, we will be using some part of your training as in testing, and that we will be using at a later point of the time to quantify or to test it, how my model is going to work for my instances on which it has not been trained. Let me further clarify it. So like suppose you are having 1, 2, 3, 4, 5, 6. Let's take it as in 10 only, right? So suppose these instances I might be using as my training, and these set of the instances I might be using as a test. Okay. So when we are going to use it as in the training one, when I'm, oh sorry, 1, 2, 3, 5. So when I'm going to use it as in training, so once, so based upon the training, I will be preparing my model, right? So what we are going to do is we are going to test it, how it is going to work on the train one to check it. Yes, it is working correctly. So if you are satisfied, we are going to deploy that model. So when you are going to deploy it, I will be testing on your unseen data, because I have trained it on 1 to 8. I haven't trained it on your 9 on 10, but I want to test it if I have not trained my model on 9 and 10, how it's going to work. Because the actual task is not to create a model for, means basically not to create a model for the case for which we are already having an information. We want to prepare the model for a case for which we are not having much information, right? That is the case. So here I want to test how it's going to work if it is if I'm going to supply some new instances for which I haven't trained it. So here I'm going to supply this, and then I'm going to test it how good it is going to work. So like suppose the model here 1 and this is 0, and suppose if it is getting 0 and 1, for example. So that means my model is just working good on the training instances. It is not going to work on your test instance. So that means I again need to do the refinement. Something is missing in some information is missing in my model. So that's why it is, or my model has overfitted on your training data. Because of that, it is working good on my training instances, but it is not working correctly on my test instances. So that way we can quantify the performance of the model in terms of your accuracy, and that too with respect to your training instances also, and with respect to your test instances also. Okay, so hopefully I am able to clear this part, the training and accuracy. Okay. Machine learning model and the machine learning algorithm is different thing for same. So basically, you will be using the learning algorithm in order to prepare the model. Okay. Yes, Chetna ji, hopefully that part is clear. We will be using the learning algorithm to prepare the model, and what this model is going to look like, so that I will be explaining in your coming slides. Yes, because as we are starting, as we have just started with your introduction part, so that's why I haven't considered this validations. So yes, validations that is also required to quantify how good your model is going to work for your unknown instance. So again, it is going to relate it to testing parts. And the hyperparameter adjustment is going to happen at times. But as we are starting it, so that's why I haven't included this validations. So now what are the branches? What are the different kinds of the learning algorithm? So there are majorly 3 branches of the learning algorithm. The first one is your supervised learning, unsupervised learning, and the reinforcement learning. Majorly, we are going to discuss about your supervised learning. Yes, I will be explaining what this supervised and unsupervised. So what this supervised is basically, in case I will be discussing, I will be giving a very brief introduction related to the reinforcement and the unsupervised learning. Majorly, we are going to discuss about what this supervised learning is, what this classification and regression is, and more specifically, we will be covering this regression in more detail. Okay. Now, what this supervised learning is? So basically, in case of your supervised machine learning approach, here you are having some known example. Basically, this is also referred as your learning by example. Learning by example, that means to know if this is the pattern, then what should be the class, right? Suppose here you are having someone to guide you. Like suppose if you are saying if the shape is round and the color is red, then the fruit is going to be apple. If the shape is long and it's some yellowish in the color, so in that case it is going to be a banana. So in that case, what the thing is, you know, if this is the pattern, then what is the class. So in case of a supervised learning, whether it's your regression problem or whether it's your classification, in both the cases we will be using this information in order to you prepare your model. So this model building process is going to be driven with your example. The kind of the example and the class level information which you are going to put it, based upon that it is going to work. And in all the learning model, basically we are trying to learn the function, and that function is going to help you to map your input to your output. So basically what the case is, you are basically trying to learn that function, where in that function you are just going to supply your x and this is going to be give you the y. So that function we will be trying to learn in all this learning model. So the objective is try to learn a function which is going to help you to map your input to your output. So this x, majorly this x we will be using as an input, and this y we are going to refer it as in the output. Like the example which we have covered related to your patient. The patient detail is going to be is your input, and what is the class, whether the person is having a disease or not. So that is going to be your final data. Now, how this supervised learning algorithm is going to work. So this little bit of description we have already covered how the supervised learning is going to work. So now, in case of a supervised learning, you are going to have your training instances. In training instances, basically this whole are going to be your training instance. So this complete is going to be your training instance. So this is going to be a sample. So here we are having the m number of the sample, and with respect to each sample, you will be having each of the samples you will be you are going to represent in terms of some information, in terms of some of the features. So these all are going to be your feature sets. So each of the sample has been described with respect to your set of the features. And this expected result that you are able to see, so basically this is defining your class. So now you are going to provide these two information into this model. And now this model is going to learn from the data. And once it is able to learn from the data, you will be doing this prediction. Now, once you are done with the prediction, you are going to compare how good it is working. If it is how good it is performing on your supplied instance. If you are satisfied with the performance, so the error term which you are able to see, if you are satisfied with the performance, so in that case, you can deploy that model. If you are not satisfied with the performance, you are going to repeat this process number of the time. Okay. Now, in the whole process, basically what we are trying to do. So in this whole process, basically we are trying to adjust the parameter of the model. So all this model building process is just going to move around your parameter. So with respect to each learning algorithms, you are going to have some defined sets of the parameter, and during the learning process, we are going to adjust the value of the parameters. So this adjustment, it's not just going to be a random adjustment. This adjustment we are going to do based upon your training instances. So, and once you are done with the adjustment, and so that means you are done with your model building process. And once you are done with this model building process, we can use it for the prediction. So once you're done with this, it is not required to include this training instances, because all this information which this training instances are holding, all these information you have already included in this model. Right. So once you are done with this, it is not required. Now I can use this model. Means if you are having this model, whether you are having this training instances or not, you will be still able to make the prediction. So this model is the important one. And in order to prepare this model, this training is going to be. the backbone of this model, because this model is going to be prepared based upon the model is you will be able to create this model based upon your training instance. Now, what are the two different kinds of the learning in your supervised? The first one is your classification, and next one is your regression. So in case of a classification, like you could see, like the things which I was talking about related to your learning, and that learning with respect to the iterative learning. Like suppose this you could see, this is your model. In both the cases, the line which you are able to see, this is your model. And now over the number of iteration that you can match it from here. So over the number of iteration, the line is going to adjust itself in this given boundary. And once you are done with this, so this line I will be using, like the final line, like this line I will be using to do my final prediction. At that time, I am not going to use this yellow one or this blue one to do my prediction. I will be just using this red line in order to do my prediction. And that too with respect to the classification also, and with respect to the regression. Now, what kind of the difference? Okay, that part I will cover in your next slides. What the classification and regression, in what term this classification and regression is different from each other, and in what term this classification and regression are having similarity. Okay, so basically, the question is related to whether we are using the testing instances again when you are going to quantify the performance. I think I am able to understand it correctly. So after the detecting error, do we use the same testing data again or the new set of the data? So basically, okay. The training and testing phase, which I have explained you. So in your training phase, what we have done is basically this 1 to 100 all your data, for example. So there are different ways to prepare your model. So the very simplistic one is your train test split. There are other variation also, but for now, I'm just going to cover this train test split. As we are starting to that, so I'm not going in a very depth, a very basic thing here I'm explaining the train test split. So in case of your train test split, basically you will be using this particular instance in order to train your model. That means I will be using this instance in order to basically locate the location of this particular line. In order to place the line in a given space, I will be using the information which is present in my tree. Once you are done with this process, so at that time you are also going to quantify how good this placement is, right? And then how you are able to do it. So for that you will be using this, how good it is performing on your training. Okay. Once you are done with this process, I will be using this splitted part in order to test it how the model is going to work on the case for which I haven't trained it. So these two are very different. So in the first case, in your iterative process, you will be using this training instance, and in your next phase, that is your testing phase, I will be using these supplied set of instances. There are other variation also, like the cross-fold variation also. So here you will be dividing your whole instance into your k fold. So k minus 1 you will be using as in training, and the last one you will be using as an testing. And that process we are going to repeat it at the number of that time. But for now, we are just going to see it with respect to your train test split. So the iterative process, you will be using this part, and your testing phase, or once you are done with the model building process, you will be using this particular part. Okay, so hopefully this part is clear. So now coming to the what are the different learning algorithms which are present. So the first, in case of your regression, you are having these learning algorithms, and majorly I will be covering these part in today's discussion. And in case of a classification algorithm, we are going to have these set of the learning algorithm, right? So I am going to cover this regression and classification, what terms these two things are going to differ. So let's first understand what this supervised learning and unsupervised learning and your reinforcement learning is. Then we will move to your supervised learning part. So in that case, I will explain the regression and your classification. Now, what are the use case or what are the example of a supervisor? In what case we can use this supervisor? Suppose the one very basic thing which we have just covered is the disease, like the person is having a disease or not. So that is one of the case. Now, if you want to predict the weather forecast, so for that also we can use this supervised learning. If you want to work with the authentication, or if you want to work with the tagging of the different object which is present in a particular image. So for that also we can use this supervised learning. So these are not a very exhaustive list in what case we can use it supervised learning. But yes, this is going to give you a little bit of idea about in what case we can go for your supervised learning. Coming to your unsupervised learning. So in case of your unsupervised learning, basically we are not using the class level information. We are just using the information with basically we are just going to use the information which is present in your data. We are just ignoring your class level information. We are not using the class level information in order to prepare the model. So this learning, this particular learning is known as a learning which you experience. And here no one is there to guide you. Like this is the learning by your own. You are basically you are trying different things, and based upon that you are having some positive or negative feedback. Based upon that, again you are going to adjust it in that way. Basically you are going to work. So this unsupervised learning is here you are going to learn from your unlabeled, not in labeled data. Okay, so one of the case is your clustering. So in case of a clustering, what the terms, how it's going to work. So basically you are having the different sets of the instances. Like here you could see, here you are having a different kind of different objects you are having. So all these objects are different in color, different in shape, different in dimension. So now this unsupervised learning is, it is going to analyze the information which is present in all these different shape and color. And now based upon that, it is going to create the groups. Like these set of the objects are having similar kind of the properties. These set of the objects are having similar, and this one is similar, this one is similar, this one is similar, and this one is similar. Right. So here in this case, based upon the kind of the characteristics of properties these instances are holding, based upon that it is going to create the group. So here we are not using the class level information. We are just using the properties, or we are just using the characteristic which is present in your data, and based upon that we are going to do the we are basically going to do the grouping groups we are going to create it based upon this. So these are the some of the clustering algorithm. K means hierarchical. Again, there is a many more clustering algorithms are there which you could use for this grouping task. But here I have just listed the three of them. It's not a very exhaustive. Now coming to your what could be your use cases. So like in the use this wherever you would like to, like suppose if you are not having the class level information, still you would like to draw some kind of the pattern, some kind of the grouping you would like to create it. So in all those cases, you will find the application of your unsupervised learning. Like suppose here you are having the set of the peoples you are having, right? So in these set of the peoples are going to have different kinds of properties they are going to. So now based upon those properties here, what you have created these. Now here in this case also, so in this case also you are having different kinds of the people you are peoples are there. Now based upon what kind of the behavior they are having, or what kind of the knowledge, or what kind of the dressing they are having, so or what kind of the background they are having. So based upon these information, you are going to create the different sets of people. So in this case also, we can use this clustering on the unsupervised learning in order to create, or in order to create this grouping. Coming to your reinforcement learning. So basically this reinforcement learning here, it is completely, it is based upon your exploration and your exploitation concept. So all your learning process is going to be driven between these two, exploration and your exploitation. Exploration, that means trying new dimension, that you can relate it trying completely different dimension, trying or exploring or basically discovering your new dimension. And exploitation means, that means whatever knowledge you are having, that you are refining. So in case of a reinforcement learning, it is working based upon the exploration and exploitation, searching the new dimension. Along with that, also using the knowledge which it is having. So based upon that, it is going to learn. So now this agent is going to work in the environment, and based upon the working of the environment, some positive or negative feedback it is going to have. So this positive or negative feedback this agent is going to hold. So whenever it is going to take the next action, it is going to use that knowledge in order to proceed further, in order to take next action in the given environment. So that way, this reinforcement learning is going to work. Okay. So if we summarize all this supervised, unsupervised, and reinforcement learning is, so in case of a supervised learning, we are going to learn from the data. In case of the unsupervised learning, that too with your label data. Here in this case, we will be discovering the pattern or the information from the unlabeled data. And in the last case, we are going to learn based upon the debate or reward, whatever the environment is going to be. So these are your different kinds of the learning and different kinds of the branches which you are having for the machine learning. So hopefully till this part it is clear to everyone what this supervised learning is all about. Now next we are going to proceed further with the more detailed description related to your supervised learning. Now one of the point which I have mentioned, in case of your supervised learning, basically there are two kinds of the learning. The first one is your regression and the classification. So in case of a classification, when you would like to when your task is the discrete classification. So in that case, we will go with the classification. When it's your means when you would like to predict the value in terms of the discrete. So for that, we will go with the classification, and when the task is to predict the continuous value. So for that, we will go with the regression. So classification, that means like that you can relate it whether the image is what kind of the digit the image is holding, or whether the person is having the disease, or it could be related to whether today the environment is going to be hot or it's going to be cold. So in all these cases, what your task is, you would like to predict a discrete class. So in that cases, for all those cases, we will be using the classification. In the another case, like suppose you want to, what will be the temperature, what will be the if this is the if this is the area of your house, what will be the price of the house? In that case, it is also the continuous value prediction, right? So in this case, if the value is the label which you would like to predict, if it is a continuous, so we will go with the regression, and if it is a discrete, so in that case we will go with the classification. This is going to be difference between these two. And if we talk about the similarity, both comes under your supervised learning. That means we will be using the instances, and we are also going to use the class value or class level information in order to prepare your model. In both the cases, whether it's a classification or whether it's a regression, in both the cases, we will be using your training instances. That means we will be using your instances along with the class level information in order to learn that function. Like as I mentioned, in all the cases, basically, we are trying to learn a function S, which is going to help you to map your X into Y. So this mapping, in both the cases, in order to learn it, we will be using the instances along with the class label. That will be the case. This is the similarity between these two, and the difference is going to be here we will be doing the prediction for this discrete class. Here the objective is to basically get to know about the discrete class, and here the objective is to get to know about the continuous class. So that is the difference between these two. So this thing we have already covered. Coming to this is the case with which you can relate it. In what case you can go for the regression, in what case you can go for the classification. Like both the cases, like the first one or the second one. In both the cases, all are talking about related to your weather. But in the first case, it is talking about the temperature. In the second case, it is talking about whether it's going to be hot or whether it's going to be cool. So in both the cases, the information which you are going to provide, so in both the cases, it's the same, but the class value or class level which you would like to predict, that is different. In the first case, it is talking about the continuous value, and in the another case, it is talking about the discrete class. So that that will be the difference between your regression and your classification. Okay, so if we summarize all these part, your supervised learning part, so here you could see this all your instance, like here you are able to see all these boxes. So all these boxes are basically representing your instance. So for now, it has been just displayed in terms of your different kind of the shape. But these different, it is not just these instances are not just holding the shape information. It is also going to contain the information related to your color, related to your weight, or related to your width. These kinds of the things could be there. But for now, what we are going to see means in what way we are going to relate it. Just take it as in a simple way. So we are just going to take it as in the shape only. Means we are just having these different kind of the shape. And with respect to each of the instances, you are having this class level information. So this is your class level, the hexagon or a square or triangle, which you are able to see. So this is just representing the different kind of the classes which you are having for your supplied instances. So now so now here what the case is, you are going to supply your labeled data. And next, you are also going to you are going to supply your instances. So these all are your instances. Along with that, you are also going to supply your class labels or class labels. So these all are just representing that you are having three different classes. Now, based upon it is not the case we are just having the value for your three instances. It is not the case. It is the case which this particular part is representing is you are just having the three class label. It is the unique class that just it is representing. But yes, with respect to all these instances, you are going to have the class. It is not the case we are just having the class label for your three instances. The case is you are going to have the class label for each of the instances, and these class label is going to be one of them. Okay, now here what we are going to do is we are going to prepare the models. As this part also I have mentioned, this is going to be iterative process. It is not just one time process. You have just fetched this instances and you are done with the model building process. This process is going to be continue for a number of the times till the point you are not satisfied with the performance. Once you are done with this, we are going to deploy that model. Next, what we are going to do is we are going to supply these instances. Means we are just going to supply your test instance. So here you could see we are just supplying your data. Like here it is written, you are just supplying your data. You are not supplying your label. So now based upon this, based upon the learned information, it is going to say it as whether it's a square or whether it's a triangle. And now based upon this, we are going to quantify how good my model is going to work when I am going to test it for your unknown instance or your test instance. Okay, so that is the case with respect to your supervised learning. Coming down to your regression part. So in case of your regression part, all the parts are going to be the same. That means you will be supplying your data. At the end, you are going to have your you are going to prepare that model, and once you are going to prepare that model, you will be using for your test. Okay, so now this middle part which you are able to see, this middle part will be different for your classification and for your the regression part. In both the cases, again repeating this part, in both the cases you are going to basically learn that function which is going to map your x into y, right? Here you will be supplying your x, that is your training instances you are going to supply. Now based upon this training instance, it is going to learn this model, and once you are done with this model building process, I can use it for the classification. Now here it's going to be here it's going to be continuous class, so that's why it's going to be regression problem. Now let's relate it in what cases we can use this regression algorithm. Suppose the task is to predicting the salary of the student. Right. So in order to predict the salary of the student, so first thing is what your task is, prediction of your salary, right? Now, what is going to be, what things I can supply as an experience? So this part is going to be, we will be supplying the information of the previous student. Means we will be supplying the student means their performance, what kind of the project the student have done, and by doing all these activity, what was their salary. So this I will be supplying as my training instance. Okay, so once you are done with this process, you are going to prepare that model and you can use it for the testing. So now here the main thing is, here the prediction is going to be a salary. The salary we would like to predict it, and that is your continuous step. So we are going to use the regression. Now coming to your tweet popularity. In case of popularity, again it is talking about some value it is talking about. So here in this case, in order to basically check it the popularity of a tweet, so first what we are going to do is we are going to train your model. This training of the model is going to be based upon the previous tweets. Means for the different users, you are having the different kinds of the tweets you are having. You're going to use the information of all those tweets, like the account information of the person, like how many followers the person is having, how many followers the person is having, or the features of your tweet, hashtag of your hashtag which has been included. So based upon these set of the information, again you will be preparing this model, and once you are done with it, you can use it for the prediction. Means if I'm going to supply my tweet, the model is going to say it, whether it means it's going to be popular or not, how many people is going to retweet my tweet. So that is the case. So in both the cases, whether we talk about the salary or whether you talk about the tweet, in both the cases, the prediction is going to be for your continuous one. But yes, in both the cases, the information which you are going to supply, that will be different. In the first case, it is related to the student. In the second case, it is related to your tweet or account information. Right? So whatever kinds of the task you are having, based upon that task, you will be preparing your model. Okay. So in case of, okay, let me see if any question. Okay. Yes, so we can use it for the classification problem. Yes, definitely we can go for the classification. The learning, like, yes, your supervised, unsupervised, yes, all these learning can be used for the image. Okay. Coming to your regression analysis. So in case of a regression analysis, basically what the main objective is. So basically we are trying to learn the relationship between your independent and dependent variable. Now what these new terms are, independent and dependent variable. So this independent variable, basically it's going to be your features with which you are basically explaining your instance, and its value is not going to depend upon the another variable. So that those variables are going to be independent, and the dependent variable is basically your class label. The class label is the class value. It's going to change based upon what kinds of the independent variable values you are going to supply. So your instance, which you have explained with respect to your features, so that we will be referring it as in the independent variable, and the class label or the class value which you are having, so that we are going to define in terms of a dependent variable. And in order to denote it, we will be using this x and y. So this x we will be using in order to denote your independent one, and y we will be using in order to denote your dependent one. That means x for your data and y for your class label we are going to use it. Coming to your case study, let's relate this or explain this your regression analysis with respect to your house price prediction problem. So now what the case is, here the case is like, suppose if I would like to predict the price of my house. So it should not be just a random prediction. It should be based upon some intelligence should be there whenever I'm predicting the price of my house. So I need a system which could help me to predict the price of my house. So for in this case, we can use the regression. And in what way we can use it? So basically, we can have the previous history of the houses along with the selling price, and then we can use it. Now, before moving into this particular detail, first relate it with you exactly how the regression is going to help you in this. Now, here what the task is to predict the price of my house. So in case of the price prediction, so basically I need to first figure it out what is going to be a dependent variable and what is going to be an independent variable. So the price is going to depend upon the, like suppose just one variable or one feature I'm taking, the size of your house. So if the price of my if the size of my house is this one, then the price is going to be this. If I'm changing the size of my house, the price is going to change. So here in this case, the price is going to be a dependent variable and the size of the house is going to be my independent variable. So now I have formulated my dependent and independent variable. So this is going to be my dependent variable and this is going to be my independent. That means we are going to refer it as an X and this part I am going to refer it as an Y. So here in means how we will be using this regression and algorithm for my prediction. So here basically in order to prepare, so first thing is the preparation of your model. And before that, in order to prepare the model, I need to have the data. Now, what kind of the data we could have in this? So in this particular case, different houses, that part I have just mentioned, different houses along with their selling price. So that is going to work as in the experience, so that is going to work as a data in order to prepare the model for the price prediction. So this all little boxes which you are able to see. So this is just representing the case. I am going to supply the houses along with the price. And these two information I am going to, from these two information, I am going to learn the I'm going to learn my model. And once we are done with the model building process, I am going to supply. Now this is my house. I am going to test it. If this is the size of my house, then what is going to be the price of my house? So that way we are going to use it for the prediction. Okay. Now, like the example which I have explained you, in that particular example, I have just used one feature. But in real scenario, it's not going to be the case. We are just going to have one feature, and based upon that feature only, we are going to do the prediction. You in an real scenario, you are going to have multiple features. So if you are working just one feature, you are working with the one feature. So in that case, it is going to refer it as a simple regression model. Okay, and when you are having the multiple features, so in that case it is going to refer as a multiple regression or multivariate regression model. Like in case of a house price, it could be size of your house, number of the bedroom, age, location. These could be the features for your houses. Right. So when the only one feature involved, so in that case it is going to be simple, and when the multiple features are involved, so in that case it is going to be referred as a multiple regression or multivariate regression. So all the things first I will be explaining with respect to a simple linear regression, then we will extend it for your this multiple regression. So first we are going to start it with the linear one, and then you can easily extend it with your multi also. So in case of a simple linear regression, basically you are just having the one feature. You are just having the one feature, and based upon that feature, you are trying to learn that function, which is going to help you to map your input into your output. Right. So let's see how exactly it is going to work. Okay, so this is again just related to the part. Basically, I will be collecting the information of all around my nearby location, and now based upon that, I will be preparing my model, and then it is going to work. Okay, so this is how it's going to look like. So this all x's which you are able to see. So these all are representing your different instances, and with respect to all your different instances, you are having this size information. Along with that, also you are having the price information. So you are having this size information, and along with that, you are also having price information. Okay. So let's see how, means now we are moving toward how exactly we are going to use it. So if you want to model the relationship between the two variables, so the one thing you can have is the scatter plot, right? You can see how the means what kind of the relationship these two variables are holding. So for that you can have this plotting. So what these dots are representing is the dot which are able to see here. These dots are just representing if the size of your house is this, then the price of house is this one. So these all dots are basically placed based upon these two information. If the size is this one, then the price is this. If the size is this one, then the price is this. And if the size is this one, and then the price is this. If the size is this one, then the price is this. Okay. So now you could see, basically this is just representing what kind of the relationship this price of your house and the size of the house are holding. So now we will be using this concept in order to basically prepare your regression model. So again, here in this case, basically we are trying to learn that. So what we have done is basically we, based upon this supplied information, we have learned that this is basically representing the relationship between your size of your house and the price of the house. I will come back to this point how we are learning this this line, but for now just take it as in the black box. Based upon these supplied information, somehow I am able to figure it out like this line is representing the relation between, if this is the size, then that is going to be the price. So now once we have learned this relationship, and now what we can have is I can use this line for my prediction. So how it's going to be, like suppose this is the size of my house. So what I can do is I just project this part onto your line, and with that projection I am able to figure it out what should be the price. So here you could see I'm not using these dots. I'm just using this line in order to do the prediction. If you're having the size of the house at this point also, so I will be able to figure it out what should be the price of my house. Okay, so now this line is just helping me to predict the price based upon your supplied X. Right? So this line is basically nothing but your model. And this model you have prepared based upon your supplied instances. This is not just a random line I have drawn. This line we have drawn, this line we have placed based upon these dots only. Based upon these dots only, we have placed these lines, placed this line, right? So we will see how the case is. Now here, this is your line. So for your line, what equation we are having? Y is equals to mx plus c. And when we are going to refer it in, like as I said, I will be using this line to do the prediction. So that means this line is basically going to be your model. So how, in a simple linear regression, how we can write this? So we can write it in this way: h theta x is equals to theta naught plus theta 1. So this theta naught and theta 1x, these are going to be the parameter of the model or the regression coefficient of the model. And this x is going to be your input which you are going to supply. Right, this point I have already mentioned. Basically, in case of all your learning algorithms, some parameters are going to be associated with it. And your task is to adjust the value of the parameter based upon the supplied information. So in case of a simple linear regression, these are going to be a parameter which you need to adjust it. And once you are done with the adjustment, I can use it. That means if I know the value of this theta naught and theta 1, so what else I need to do? I just need to supply the value of your x. And once I'm able to supply the value of the x, I will be able to do my prediction. Right? So this particular equation, now what the case is, I have basically formulated one equation. I have basically formulated this function, and this function is going to help me to it is going to help me to do my prediction, right? So hopefully till this part it is clear to everyone. because all your discussion is going to be based upon this model. So now we have formulated how your model is going to look like. Now next we will see how we can formulate the value of these, how we can formulate these value of these. Okay? Coming to your, let's now cover this parameter in more detail. So here in this case, this is your training instances. I will explain this part how we are drawing this line. So, but before that, we are going to cover all these details related to your theta naught and other parameters which are associated with your. So now these all are your points. Based upon this point, I have drawn this line. An equation for my line is theta naught plus theta 1. So this is the equation. Okay. Now what this parameter is saying is, so this theta naught is basically defining your intercept, and theta 1 is basically the slope of your regression line. So what this intercept is all about? This intercept basically, you can, in a simple example, you can relate it like, suppose whenever you are hiring any auto, so the meter is going to start, the amount is going to start with the with some value it is going to start. So that you can refer it as in the intercept. So this, the amount with which it is going to start, this is going to be this, right? And as you are going to move ahead, as you are going to progress in your journey, it is going to increase with that. But yes, the meter is going to start with this. So this is your intercept point. Intercept. So now next one is the slope of your regression line. Slope of the regression line, basically it is defined if I, like here in this case, it's related. If I'm changing the size of my house with the 1 square foot, how much change you will observe in my mind, or how much change I will have in my mind. So that is defining the slope of your regression. So if I'm changing the size of my house with 1 square foot, how much change I will have in mind. So this is representing the slope of your regression. And this complete thing is your 1. Okay, theta naught plus theta 1 x. So how this whole estimation process is going to be? So you are starting with this particular equation. Initially, you are not having the knowledge about theta naught and theta 1. That is the parameter of your model. Here you are just having your training instance where you are having the x and you are having the 1. Based upon these two information, you are going to adjust the value of this. Once you are able to do the adjustment, you are able to prepare the model, and at the end, you are also able to know what is the value of my theta naught and theta 1. And that is basically representing your model. And once you are done with this process, I can use it for the regression program. Okay. So now, hopefully till this part, it is clear to everyone. Yes, yes, I'm coming back to the point when it is going to be complex. For now, we are just covering we are starting with a very basic one, and then, sorry, then I will extend it with your, if the data is complex, then how it's going to work. Now here in this case, so what your objective is? Our objective is the line which you are drawing. That should basically contain all the information which is present in your training instance. So basically, what is the meaning of it? Basically, it should be a very good representative of your training instance. So what our objective is? Our objective is to place my line in such a way that it should represent all these instances. Right. So that means the gap which you are having, that should be less. And why is it the case? Because this gap is basically nothing but your error part. According to your data, that should be the case. That means if the size of my house is this one, then the price should be this. Right. But according to your model, what it is saying is, the size of your house is this one, then the price should be this. So this much of error your model is. So our objective is to minimize this gap. to minimize this gap which you are having. Then only I can say it the model or the line which I have drawn, that is the representative of my instance. Right. So now here in this case, this much of gap you are having. So that means it is representing my instance, it is representing my training instance, but not completely. So the value which you are able to see here, so these values are just, this is your actual thing, this is your actual class level, but according to your model, this is the class. That means this is your actual class value and this is your predicted class value. Right. So we wanted to minimize this gap. And this minimization you will be doing over the number of that I have taught. It is not the case you are just applying your instance. You have done some random adjustment in your value and that's all. It is not the case. I need to adjust it. I need to place this model in such a way, or I need to draw this line in such a way that it should be a clear representative of your instance. So that is our main objective. So that is the case. So means one more important point is we are interested in to minimize the gap. We are not much interested whether it's a positive gap or whether it's a negative gap. That means whether I am doing in this way or whether I am doing in this way, it's not going to make the difference. Whether it's to 2 or -2 or whether it's to +2. We are interested, there is a gap. Means we are interested on this 2. We are not interested whether it's a positive one or whether it's a negative. So in both way you can write it. Right? In order to summarize, we are having a gap. We are just interested that we are having a gap. We are not we are not much interested whether it's a positive gap or whether it's a negative gap. Gap here we are just referring it in the gap. It could be a positive, it could be a negative. Okay. So that part I have just explained you, like in order to means this is your predicted one, this is your actual one, and this is your gap. Right. So when you are going to do this, you will have the actual class value. So that's why what we want to minimize this gap, and this gap we are referring it as the error. So we would like to minimize this error so that I can have the correct prediction. Okay, so let's see, before moving into further detail how this error part we are going to adjust it. First, we are going to see how the placement of the line is going to differ, or it's going to how the placement of the line is going to be for the different value of your theta. So first we will be exploring this part and then we will go for your error part. So now here you could see, suppose these are all are your value 1, 2, 3. Right? Now here in this case, this is the first equation. Just a random equation has been written here. This is the second equation and this is your third equation. Now we are going to see, based upon this equation, what will be my predicted value for my given x. So if the value, if I'm taking this one, 1.5 plus 0 into x, right? This is the case. Suppose using some way I have derived these three combinations. In the first one, theta naught is 1.5 and theta 1 is 0. In the another case, theta naught is 0 and the another case, theta 1 is 0.5. And in the third case, theta naught is 1 and theta 1 is 0.5. Now let's see, based upon these three different values, how the prediction is going to be different. So suppose if you are taking this one, right? So for this value, what will be your prediction? It's going to be 1.5 plus 0 into 1. It's going to be 1.51. For this one, 1.5 plus 0 into 2. It's going to be 1.5. For third one also 1.5 plus 0 into 3. It's going to be 1.5. So irrespective whatever value you are going to supply, all the time it's going to be 1.5. So the placement is going to be this one only, this line which I have just drawn. So that will be the placement. Okay. Coming to the another part, like suppose instead of this, let's take the another one. Suppose we are taking it as a 0.5. So in case of the, hopefully all of you are also able to relate it. In case of your 0.5, what the case is, like it's your 0, means the theta naught, it is not having any contribution. Just theta 1, it's going to contribute. So 0.5, that means for your 1, it's going to be 0.5. For your 2, it's going to be 1. For this, it's going to be 1.5. So that means for your 1, it's going to be 0.5. For 2, it's going to be 1. For your 3, it's going to be 1.5. Right? So this will be the placement when it's your this. Coming to the third one, so third one also, hopefully all of you are able to calculate it. This is going to be the place. So now you could see the line is going to be based. The line, basically the line which we have drawn, it's going to be completely driven with what parameters you have selected. Although this part is same for all three cases, means you are having x is equal to 1, 2, 3 only. But the placement of the line is going to be completely depend upon what theta naught and theta 1 you have selected. Okay, coming to the another part of it. So as the value of the placement is different, the class value which you will be predicting for your unknown instance, so that is also going to be driven with the with that particular selection. So now here you could see you are having 2.5. Suppose if you are going to supply 2.5, in this particular case, it is going to give you 1.5. And for this particular case, it is giving 2.25. So for the same input, you are going to get the different output as the selection of your theta naught and theta 1 is different. Okay. So for the same data set, you could have the different placement of the line. But what our objective is? Our objective should be to minimize the gap as much as possible. So that should be the objective. Right? So let's come to your coming to your this error part. So basically, what the case is, your yi is going to be your theta naught plus theta 1 xi. This is just representing instance, and this is your error which you are having, the gap which you are having between your actual and the predicted. So this error could be written in this one. The difference between the actual and the predicted. This is going to define your error. This is the error with respect to your ith instance. But this is not case with your one instance. This will be the case for your all your instances. It will be the case for 1, 2, or whatever number of instances you are having. So in order to calculate the complete or total error for all your instances, we will be using this. So this is the with respect to first, second, third. That way we will be using for all your instances. So this complete is going to define the total error which you are having for all your trainings, and that to define in terms of your cost. So this particular formula, this particular equation, we will be using in order to define your cost. So this is the cost, and this cost we would like to minimize it. How the minimization is going to be? If this gap is less, like if all these gaps are less, that means in whole this cost is going to be less, and that is our objective. Okay. So if summarize this this first part, so basically what our objective is to minimize this gap. Okay, this 2 and this 2 has been just written for a mathematical simplification, and this is just to calculate the average of, like you are calculating basically the summation of all your instances. So in order to calculate the average, this thing has been introduced, and this 2 and this 2, basically these two things has been just used for the mathematical simplification. Okay. Now this is your cost function. So this cost function is going to be driven with your theta naught and theta. Okay. So now the first part we have seen how the placement of the line is going to be affected based upon the different selection of your theta naught and theta 1. Now next we are going to see how this placement is going to basically affect your cost function. That we are going to see. Okay. Now again, in order to simplify it further, I will be explaining this error part with respect to your one parameter. You can extend it with the multiple also, but for the simplification, I will be explaining with respect to the one parameter. Okay. So what the cost function is? So now here the cost function is going to be j theta 1. So I will be just walking on your theta 1 part. Suppose here we are having the two instances. Okay, so this is 1 and 2, and this is the class label also, it has been taken as a 1 and 2. You can take it another value also, but again, for the simplicity also, this 1 2 1 2 has been taken. You can replace it with the another value, or any number of the dimension you can extend it. That you can take it. Okay. So now here let's see how the cost function is going to be affected based upon this theta. Suppose the equation is your theta 1x, right? Now theta 1 is equals to 1. Now, so what we need to do is we need to calculate your cost, and the equation for your cost is going to be difference between the actual and the predicted one. So here in this case, the actual is 1. Like for this case, I'm talking about this one. The actual is 1, right? And predicted, that means 1 into 1, right? According to this one, it's going to be 1 into 1 only. So it's going to be 1. Actual is 1 and predicted is also 1. So the difference is going to be 0. Now in the next case, actual is 2. So this is 2. Predicted is also you are getting as an 2. So this is also going to be 2 minus 2. So that is also going to be 0. So this is your difference between the actual and predicted for your first instance, and this is the difference between the actual and predicted with respect to your first instance. And this is the formula which we are covering. Like this is the formula. Okay. So whole thing is going to be 0. That means if the value of your theta 1 is 1, then we are not going to have any cost. The cost is 0. That means we are like, for 1 we are predicting 1, for 2 we are predicting 2. So that means there is no difference between the actual and predicted one. So if there is no difference, so that means the cost is 0. Coming to the another part. Here in this case, again the equation is same, theta 1 and 1 into x, but the value for your theta 1 has changed from 1 now it's your 1.5. Now let's see how it is going to work. So the equation was for your x1, this is your x and y, this is your 2 and 2. So that was the case. Let's see. So for your 1, so that means 1 into 1.5. Like this is the case. So it's going to be 1.5. So actual is your 1, and what you are getting, predicted you are getting it as in the 1.5. So actual is your 1 and predicted you are getting 1.5. That is the first case. Coming to the next one, so here it's going to be 1.5 into 2. So it's going to be 3, right? So here in this case, actual is 2, but you are predicting, the prediction is your 3. So actual is 2 and the prediction which you are going to do is your 3. So that means we are having a difference. So this complete, if you solve it, it's going to give you 0.5. So what is the meaning of it? When the theta 1 is 1.5, the cost is going to be this much. That is 0.5. Like you could see, this is 0.5. So for the different selection of your theta 1, you will have the different cost. So somewhat this kind of the case you will encounter. Like for the different values of your theta, you are going to get the different value of your cost. So that way, the selection of your theta matters. It's going to change the placement of the line. As it is going to change the placement of the line, it is going to change. It is going to change your calculated value. As it is going to change your calculated value, it is also going to affect your cost. So that way, the selection of your thetas are important. Now here we have done the on just one based upon just one parameter we have done it. We can extend it for your 2 also. So like here in this case, so all this plot which you are able to see here, this is just representing for the different selection of your theta naught and theta 1, what cost you are having. So this is just each of the points which are able to see. These are just representing the case where for the different selection of your theta, what is your cost. Okay. So now this is just another way to represent it. So here you could see for this particular placement, this is going to be your cost. For this particular placement, this is going to be your cost, and for this particular placement, this is going to be cost. So these all are representing For the different placement, your costs are going to be different. So all these slides I have taken from the Coursera already. So yes, coming to this part. So next, coming to your summary of this first part. So we have derived the hypothesis, basically what our model. The model is going to be theta naught plus theta 1 is. What are the parameters associated with your model? The parameters are your theta naught, and this is the complete model, right? This is the complete model. In this model, you are having theta naught and theta 1. This is your cost function where we are calculating the difference between the actual and predicted one, squaring it and calculating its average also. Now what your goal is? Your goal is to minimize this. Our goal is to select a value of your theta naught and theta 1 in such a way that I could minimize this one. So this is the minimization problem. I need you to select some value of your theta naught and theta 1 in such a way that I could minimize my cost. Let's see if they are having any question. So one question is related to your cloud computing. Means for what kind of the problem you would like to use it. Means what is your task? In case of a cloud computing, what is your task? For what task you would like to use it? So if you could specify that particular task, then I can basically comment it whether it could be used or not. So if there is a centrality of error, basically this part, basically yes, if the error is used, if I'm able to get it correctly, if the error is used in that case, the performance really, the accuracy part is also going to be affected. Resource management in your cloud. So basically resource management, resource management, somewhat it is related, which I am able to get it, somewhat related to your optimization problem. So for the optimization problem, there are different kind of the optimization algorithm exists. So all those algorithms, you can use it for the resource management. So like there are different nature inspired algorithm or other algorithms are also there. So for this particular task, you can use it optimization. One of the optimization algorithm, we are also going to use it in this case also, like this minimization, like what I mentioned here is the minimization of your this particular cost, right? We are talking about the minimization of your j theta naught and theta 1. So here it is related to your I need you to select the parameter theta naught and theta 1 in such a way that I could minimize this. So this is your optimization. So I will be explaining one of the optimization algorithm to derive this value. So for those set of the problem, you can also test it. You can go with the optimization. Okay, so now next what we are going to see is we are going to see how we can now we have understood what this model is all about, and how the performance is going to be affected based upon the selection of your theta naught and theta 1, how we can use the created model for the prediction. So hopefully all of you are able to get it, these points related to your regression analysis. Now next come down to your the selection of your parameters. So now in case of the selection of the parameters, basically there are different ways to basically do the selection, basically to derive the value. The one way, the very basic one, it could be related to your basically randomly selecting any value, and with that random selection, we are basically going to work with. So here this random selection is not going to help you. By chance, if you have selected a very good value, then in that case, well and good. If not, then in that case, it is not going to help you to do the prediction in a very accurate way. Because the selection which we have done that was just the random selection, which random selection has been done. So the random selection is not going to help you much. So there should be some way with which I can derive this. So this is one of the way with which you can derive. So this is just a very simple mathematical calculation we need to perform in order to derive the value of your theta naught and theta 1. So like here in this case, hopefully all of you can get it. So this is just the calculating the multiplication of your x and y, then performing the summation. Here we are squaring this term. Here we are first doing the summing up and then squaring it. Here in this case, summing up your x and y, then doing the multiplication. So once you are able to derive this theta 1, based upon this theta 1, I can derive my theta naught also. Okay, so now let's see with an example. Suppose example, very simple example it is. So like suppose this is related to your selling thing. So if these many hours of sunshine is there, then how many ice cream you will be able to sold it? How many ice cream basically you will be able to. So basically least square method, the method which I have covered here, the least square method, basically it is talking about this one. Basically here it is talking about this is the subtraction of your actual and the minimum, actual and the predicted part. So basically how we are going to derive the value, how we are going to basically minimize this value. So that we are going to, that basically going to come under this. Okay. So yes. So here in this case, what it is going to be. So basically, okay. The problem is here the sun. If these many hours of sunshine is there, how many ice cream you are able to sell? So that is the case, right? So this is your data for your first day, second day, third, fourth, and fifth. Till fifth day, this is your data. Okay. Now next, what we needed to do is we needed to calculate basically. You need to calculate the case. You need to prepare the model. Like if you know what is the how many hours of the sunshine is going to be there. So what will be your selling? What will be the selling of your ice cream? So that basically we would like to prepare the model for this. So in order to prepare this model, again this is the prediction related to your some value. So we can prepare a regression model, and based upon that regression model, we can use it for prediction. So the formula which I have explained you, so this is just based upon this formula. So first squaring it, then doing the multiplication and base. So this is going to be the case. Okay. So what the value is? So here theta 1 is 1.5183, and here theta naught which you are having is 0. Theta naught is going to be 0.3049. So that's all of you can do this part. Just it's based upon this calculation. Right? So now we are having theta naught as in 0.3049, and this theta 1 is going to be 1.518. So now we know what is the value of your theta naught and theta 1. I can simply place my x, and based upon that placement, I will be able to calculate them. So here in this case, suppose we know it is going to be for 8 hours. So that means it is going to be nearly this much of ice cream I will be able to. This 12.45, it's that you can take it as in the floor or the ceiling, you can take it. So this much of ice cream I will be able to sell. I will be able to sell it. So here in this case, what the scenario, you are having the hours of sunshine and the how many ice cream you can sold. So based upon that, I have prepared my model. This model is going to be look like this: theta naught and theta 1x. I have derived these theta naught and theta 1 based upon my previous history. Once we are able to done it, I am going to use this predicted value, derived value, in order to do my prediction. So that way I can use the regression regression algorithm, I can use it for predicting the continuous. So yes, is it clear to everyone? Yes, do you have any doubt till this point? Okay. So this is I mean, the point which I have discussed. This is one of the way to predict the or to calculate the value of your theta naught and theta one. So now there could be the another way, like one point which I have mentioned in your earlier discussion is here in this case basically you are having means you are basically calculating the value of your theta naught and theta one over the number of iteration. But here what we have done, we have just derived one value and we are using it. So this is the static approach where we are not updating it. We have just formulated the value at your one go and we are going to use it throughout your throughout all the process. Now, could it be the another way where we can iterate over the process where I can check how my model is going to going to work on the current selection, and if I can I update it further to satisfy to refine it further. So this could also be done. The way to do is using the optimization algorithm, the point which has been asked also. So in case of the optimization algorithm, basically what we are going to do is we are going to supply your function, and this the algorithm is going to basically adjust or basically going to calculate the parameters or the variable associated with it, and based upon that parameter it is going to satisfy one or the another requirement. Here in this case the requirement is going to be the cost. We would like to minimize this cost, and the cost is going to be minimized based upon the selection of your theta naught and theta 1. So the function which you are having, this is your convex function in nature, so that you are going to, means in that particular case we can use this gradient descent algorithm. We can use it for this particular task. So first, related with a shape, means one kind of the shape. In that particular shape, how we are over the number of the iteration, how we are updating the value, and based upon that updation, how we are going to reach to a minimum or maximum point. So like here in this case, if you want to reach to this minimum point, so wherever you are going to start, either you need to perform the increment or you need to perform the decrement in order to reach to this particular point. Like here in this case, in order to reach to this point, sometime I need to perform the increment, sometime I need to perform decrement in order to reach to this point. So this is related to your minimization problem and this is related to your maximization problem. So based upon what kind of the objective we are having, based upon that we are going to work. Now the line which you are able to see here, so this line is basically defining the slope of change. The slope of change is going to be 0 where you are having the minimum or maximum value. For this case, if you calculate the slope of change, if you calculate the derivative of this particular, if you calculate the derivative at this position, it's going to be 0. And here in this case, if you are going to calculate the derivative at this point, it is going to be 0. But yes, in a real scenario, you could have this kind of the cases also. So yes, selection is going to be very important when you are going to encounter such kind of, because at some point you are going very deep down, at some point you are going to a very up position, in some point you might be having this case also. So in that particular case, deriving or reaching to the optimum or global optimum position, that will be quite good. Okay, let's relate it how we can reach to your the minimum or maximum position. So suppose for a point, suppose if you are starting with this particular location, for example, I needed to start somewhere. Like if I wanted to reach to this particular location, I needed to start from some location. So for example, if I'm starting with this location, and in order to reach to this location, what I need to do? I needed to perform the increment in my theta. Like this is your theta scale. So in order to reach to this point, I need to increment my theta, right? So that way I will be able to reach to this particular point. suppose if I'm instead of starting, because initially I don't know what is my location. So suppose if I'm starting with this location, so in order to reach to this point, I need to perform the decrement in my theta so that I can reach to this, right? So that means what is going to be the case? So when you calculate your derivative, when you calculate the derivative with respect to theta, and if you're getting the derivative greater than 0, so that means it is a positive slope, and that means I need to increase my theta. If you are calculating the derivative and derivative, you are getting it as on the less than 0, so that means it is your negative slope, so that means I need to perform the decrement in my theta. So let's relate it here. So whatever theta you are having, like you are going to start with this some random location. So whatever theta you are having, so in that the theta you are going to increment it or you are going to decrement it based upon what location you are present. If it is at your positive side, perform the increment. If it is at your negative side, perform the decrement. So that way you will be able to do the adjustment in the value of your theta, whether you are going to increase it or you are going to decrease. So that is the case in this particular scenario. Same is going to be for this one also. So here in this case also, basically, here in this case, like this is your minimum location, right? So in order to reach to this location, again, I will be calculating the derivative. Basically, I need to derive the slope, whether it's so positive or negative. So in this particular case, if the slope is negative, so that means in order to reach to this location, I have to perform the increment. And if you are at this location, slope is positive, so that means I need to perform the decrement in order to reach to this location. So the equation is going to be a little bit different in this. When the slope is positive, I need to perform the decrement. And when the slope is negative, I need to perform the increment. So from here, you can relate it. If it is a negative, it's going to be plus. If it is a positive, then it's going to be negative one. So that way you will be doing the adjustment in your theta, whether it's going to move in a positive direction or whether it's going to move, whether it's going to be an increment or it's going to be decrement. Yes, cost function. Okay, coming back to your cost function again. So now here in this case, you could also see one more parameter I have included. The parameter is this alpha. So now here in this case, the alpha is basically this alpha which you could see here. The alpha is basically the step size. With what amount you would like to change your current theta. It is not a straight way we were doing the subtraction or we are doing the addition. We would like to have the impact of your calculated value. We would like to basically adjust the impact of your calculated value on your current one. So that adjustment we are going to do based upon this criteria, based upon not the criteria, based upon this alpha. So now alpha, it could be a fixed one also, it could be your dynamic one also. So in your fixed one, you are having the two possible. The first one, it could be your small step size, it could be your large step size. Okay. If it is your small step size, so that means suppose you are going to start with this location. So with a very tiny step, you are going to move to this location. Yes, you will be able to reach to this location. But what will be the disadvantage? You are going to take lots of time to reach to this location. Because very tiny steps you are going to take it in order to reach to this. So yes, you will be able to reach it, but yes, it is going to take lots of time. So other solution could be take a large step. In case of a large step, you will be able to make a very long move. But the disadvantage, it could be you may overshoot your local optimum because of your step size, you're just moving in this space. You are not able to reach, you are not able to go to this particular location because you have taken a very small jump, you have taken a very large jump. So this fixed one is not going to help you much. That you can use it, but yes, appropriate selection, it's really going to matter. So now another case is instead of working with a fixed one, we can go with a dynamic one. So what we can have is initially, like initially we are assuming that you are very far from your optimum position. So initially take a very large step so that I can reach to this low optimum position very fast. But as you are progressing, decrease your step size so that you could not overshoot the optimum location. So that could be one of the criteria to select the value of your learning rate. Okay, instead of fixed, make it as an adjusted based upon the requirement. So these are the some of the common choices which researchers have tried. So instead of fixing it to a very large, and that large we are going to use it throughout the number of the iteration. Instead of doing this, take a large at your initial phase, but yes, over the number of the iteration, decrease it. Okay, so that you should not overshoot your the optimum location. Okay, so that way this selection is going to be. Okay, so now we are going to iterate through the process. With that iteration, we will be doing the adjustment in my theta naught and theta 1, and this process we are going to repeat it till we are not satisfied with your defined criteria. So like suppose this defined criteria could be 0, means until unless you are not reaching to a 0, that means minimum 1. Till the point I'm going